Right, so this is the last question now. This is question number 9 for Edexcel C3 June 2015 past paper. Now, this question, the first part, we're told that the function of x is 2 take brackets x take 5 brackets x take 6 over x squared take 3kx plus 2k squared. And we're asked to prove that is equal to x plus k over x take 2k. Now, the first step I would do, now this 2, don't let it put you off. I'm not going to focus on the 2 straight away, and there's a key reason for that. Whenever I say something like this, now, say we're going to factorise this x squared, take 3kx plus 2k squared. Now don't be put off by the fact it says 2k squared. Remember, k is just a number, so that 2k squared isn't going to end up being 3x. It's just going to be a number, just a constant. So don't let that put you off. Whenever you get something that's factorable, so this is a quadratic on the top. Now you could expand that and cancel it down, but you wouldn't get yourself into a mess. Now, what we've got at the bottom is, as I said, a quadratic. Now, the best way, if you're the kind of person like me who looks at quadratic and has to spend about 5 minutes before they can figure out what to do. Now, I'm generally quite competent at maths. I mean, I would like to think so. I mean, you're watching my videos anyway, so unless you switch off this very instant because I've said that, I'd like to think you've got some hope that I know something about maths. So, anyway, the thing that I personally like to do is cheat. And the way I cheat is one of these two factors is likely to be a factor of the bottom quadratic, because generally in these kinds of questions one's going to cancel out with the other, so you'll end up with something that says x take 2. And actually this gives you the full thing on the bottom here, because what we've got on the bottom is x take 2k. Now one of the factors is going to be one of these, because they're going to cancel out. Now that generally always happens. I've never seen a question where you get something like this and you've got a quadratic on the bottom and it doesn't cancel out with one on the top. As I said, it'd be quite unlucky for that to happen, but generally what's going to happen is we're going to have one of these factors that's on the top on the bottom, and it's going to be one of the other factors is going to be x take 2k. Now obviously you haven't got an x take 2k on the bottom, so one of these factors of this x squared is going to be an x take 2k, and the other factor is going to be one of these two. So they cancel out. Alright? Okay, so, and then this 2, I'll explain what we do with that in a minute, but for the moment, just leave it there. So it's x take 5k on the top, sorry, and x take k, and then on the bottom, if we factorise that, well, as I said, x take k or x take 5k is going to be one of the ones on the bottom. Now let's look at these ones. Well, it's not going to be x take 5k. That's because that isn't a factor of one of these two, because we'd have to reduce it, and you can't really take away something or add something because we need a positive 2k squared, remember, because our k's are going to be like the ones on the top, so you can't have a negative 5 and take away something to get 3, so it's not going to be x take 5, so therefore it must be x take k. And as we already explained, the other factor is going to be x take 2k. Okay, so it's x take k and x take 2k. So the two x take k's cancel out. So you can factorise them. So I'm just going to rub them off. So you're left with x take 5k and x take 2k. And that's 2 take away that. Now, say this on the bottom, instead of saying 2, it said 2 over x take 3k. What would you do then? Well, you do what normal, sane people would do, and make sure they have the same bottom bit or denominator. So basically, what you do there is you times x take 2k on the top of the fraction and the bottom. Now remember, this 2 is the same as saying 2 over 1, if that helps you think of it any better. So you do both top and bottom times by x take 2k, because they'd sort of cancel out and end up just times it by 1. But obviously, it's a bit more than that. So 2 times x take 2k over x take 2k, take x take 5k over x take 2k. Okay, you'd expand the top one out, so that'd be 2x take 4k. So 2x take 4k, because we're going to put it on one fraction. Take x plus 5k, because it's a double negative, over x take 2k. Now remember, we want it as x plus k, so if this all worked out, it should just delete x plus k, and it does. Well, we get rid of the 1x there because we've got an x there, and the plus k occurs, so it's just, that ends up being x plus k. And you go, as required, etc, etc, so we know that's right. Alright, so it's quite a hard little bit that, but for the last question, it's not too bad. Now this next part says, find the derivative of x and give your answer in its simplest form. Right, so again, quite a nice question. So the only rule we've got for differentiating a fraction is the quotient rule. Sorry, even if you didn't get that, you could have still used their answer for that they gave you for part A. So differential. So obviously u is going to be x plus k. Remember, k is just a number, so it could be x plus 3 if that's what k was. So therefore u dashed is just going to be 1. V is our x take 2k. Remember, our k is just a constant, so it just becomes 1. So therefore our u dash and our v dashed is 1. Our v is x take 2k and our u is x plus k. Okay, so work this through. So therefore dy dx equals v u dash take u v dashed over v squared. That's our standard quotient rule. Now you could write that out if you wanted to, but I'm going to be lazy today and not. So it's over v squared, which is x take 2 squared. Now I'm just going to leave it, sorry, x take 2k squared. I'm just going to leave it as x take 2 squared. No need to expand it or put it in double brackets. And therefore the v times the u dashed, so it's just x take 2k times 1, so it's just x take 2k. So I don't need to write the times 1, but obviously you know it's there. Take uv dash, so that's x plus k times 1. Again, don't need to write the 1 there. You are intelligent people, so you can get away with that. So it's x take 2k, take away x plus k over x take 2k squared. So if you cancel this down, the x's get rid of, and then you're left with minus 2k, take away positive k. So it's minus 3k over x take 2k squared. Okay, and that's fx. You can't do anything out of that in its simplest form. Obviously you need to, that is the full marks there. Now, part C says, state with a reason, before this, we're told that k is a negative function, which is obviously now going to have some relevance to part C, but obviously you should have picked up on that if you'd have had the exam paper. 9c says, state with a reason whether f of x, which is this function, which also, f of x is an increasing function, so it's this one, and justify your answer. So it's worth 2 marks. Now remember, you look at an increasing function or a decreasing function with the gradient. Okay, so you can't take into account this. We have to take into account the derivative, the gradient function. Now as we're told k is a negative constant, if we've got any negative number in here, negative 3 times a negative number is always going to give a positive number, and whenever we square something, that's going to turn it positive. I mean, obviously it does square the number as well, but turns it positive. So we're going to, whatever number k is, whatever negative number k is, we're always going to have a positive outcome. So the gradient is always going to be positive. So therefore, the gradient is always increasing, hence it's always an increasing function. Okay, so that's all you say for 2 marks. So you just get a mark for saying, as the top and bottom, or the numerator and denominator, are always positive, because k is a negative constant, so that's going to give a positive on the top, and obviously a positive square, a square number is always going to be positive on the bottom, or denominator, so therefore, as the gradient positive, it's an increasing function. Alright, so that's the end of the Edexcel C3 for June 2015. If you'd followed them steps, you would have got 100%. So, I mean, obviously I didn't, but anyway, so thanks for watching, and we'll see you in the next video, whenever that may be. Hopefully this video hasn't been too irritating, but try to make it as sweet and short as I possibly can, although I'm in it, so it's not that sweet or short. Anyway, so thanks for watching, and we'll see you in another video sometime, hopefully. Well, let's see you take literally. Anyway, see you later. Whoa.